Well, let's think about running multiple instances of an application on the cluster on different nodes. As you know, we may need to increase the resources available to an application actually to improve its processing capacity, for example, because of the large number of requests that come to that application. Well, the solution is to run different containers of that application, but we need a way to manage these containers. For example, if one of that containers is crashed, we need to recreate an alternative container for that, or if for any reason the node that our containers are located on it is crashed, we need to recreate that containers on other available nodes. Even more, we need a way to load balance all incoming traffics between these containers. Well, to do that, we can use Docker services. Actually, a service defines how our applications must run, including its volumes and its published ports and the number of tasks or containers as replicas that application must have. Well, a task is an object which is created by a service that is assigned to an available node for creating a container. In fact, by docker run command, we could create a standalone container on a Docker engine which is running in local mode. While by Docker services, we can create multiple instances of a service that is called task for running in a cluster of nodes or computers which their Docker engine runs on Swarm mode. In other words, a service acts as a template when instantiating tasks. For example, here if we create a service for running 3 instances or replicas of BusyBox application, actually Swarm Manager will create 3 tasks, each is associated with a container that these tasks are assigned to available nodes, and our container will be created on that node. Well, here we can use Docker service create command to actually create a service on the cluster. We can run this command if our Docker daemon is running on Swarm mode. Here we can specify a name for our service and the image that our containers must use, and the parameter which is used as a startup command in our container. Let's test this. Well, here in my client, if I check the Docker context, you see my default context is Swarm, which is connected to my master node. So all Docker commands here run on the master node. Now Docker service create this name service1 from image busybox, this parameter for actually running a sleep command for some seconds. If here we run Docker service ls, you see we've created service 1 with 1 replicas that is ready. And here we can list the containers of this service 1. Well, you see it created a container named service 1.1 from image busybox on worker 2 that each state is running. Let's use watch command to periodically see the containers of this service 1. And now if we remove this service, Docker service remove service 1 and recreate it, for example, to run for 10 seconds. You see here it tries to start the first container, and after some seconds it verifies the container is successfully created. But here after 10 seconds, it recreates another containers. In fact, because the task that our container must run is sleep for 10 seconds, after 10 seconds, our container terminates. That's why the service 1 here by default tries to recreate an alternative container. You see, the service doesn't guarantee to recreate the container on the same worker. That's why here the later containers is created on master node. So let's delete the service. And here we can use restart condition option to actually define the restart policy of the service. We can use non-value for actually disabling the restarting, or any for restarting the containers always, and on failure, which restarts the containers when they had a problem. Actually, when the main program inside the container exits with code non-zero value, the container's state is treated as failure. In that case, the service will restart that container, but in practice, it will create another container instead of restarting that container. Let's test this. Actually, here we can use restart condition with, for example, none. Well, here our container is created. After 10 seconds, it will stop. Well, its state is shut down, but the service doesn't try to restart this container. As we saw, we can use the docker service ls command to show the list of services, and docker service ps command for listing containers of a service. And here we can use docker service ps command with the list of services for showing all containers for all services. And for another example here, we can use replicas option for running multiple instances of an application by actually different containers. Let's test this. Well, here let's delete this service and recreate another service, name service 1, this option, replicas, for instance, for running 3 instances of the application from BusyBox. This parameter sleep for some seconds. Well, here you see it tries to run all replicas, and finally it verifies the tasks are done. Here we can see different instances of this BusyBox, which each running on different node. Here we have an SSH connection to our cluster nodes. Let's see containers list. You see it created a container for this service 1 and concatenated the service name in each name. Now let's restart this worker 2. Here you see it recreate another container that is located on master node instead of worker 2. Because this node doesn't run anymore, that's why the task how this container is assigned to another available node. Well, here we can use docker node ps command for actually listing containers of a specific node, for example, worker 1. While here, if we create a container, for example, docker run in detached mode, name b1 from BusyBox, sleep for some seconds. Here docker ps will show that we have 2 running containers, while here by docker node ps command we can see that new created container. Because container b1 is created in standalone mode, docker node ps command doesn't show it. Actually, it only returns containers that are created by services in swarm mode. Well, thanks to docker services, we don't care for managing multiple containers or different replicas of an application. And here, by this option, we can limit the maximum number of replicas for a specific service on one node, which by default is unlimited. And by -L option, we can assign labels to our services. For example, let's create another service 2, with label A equal to B. Now, Docker service ls will list all services, and by -f parameter, we can filter each label to be, for example, A equal to B. Sorry, label. And we can use mod option to change a service to replicated or to be global. Actually, by default, it is replicated, which allows to specify the number of replicas we need to run. And the global mode allows to assign the replicas number to the number of nodes in the cluster. Even more, it forces each container to run on different node. In fact, by global mode, we can force to run an instance of an application on every node of the cluster. Let's test this. Docker service remove service 1 and recreate it with mode global. You see it created 3 replicas, while here we didn't specify any replicas number, and each instance of the busybox is located on different nodes. Even more, if later some nodes join to the cluster, it will assign tasks of this service to that node as well, unless we've already removed this service from the cluster. And here we have another value, for example, replicated job, which is actually somehow similar to replicated services, but it actually is designed to run an operation to completion and then stop. In fact, when we need to run some containers to perform some jobs and then terminate, we can use replicated jobs. In fact, it doesn't restart the container when it terminates. I mean, if a task of a job, or actually the main program of the container, exits successfully, in fact, it returns value 0, the task is marked as completed and its container doesn't restart. Else, if the main program of the container returns a non-zero value, which in that case the container's state would be failed, and the replicated job service is responsible to restart that container. And also we can use global jobs for running job services in global mode that forces to run one job on every node of the cluster. Well, when we use Docker service create command to create a service, the lifecycle of creating that service would something like this. Actually, in our client Docker CLI, we send Docker service create command to our master API. Actually, we use Docker context to run our Docker commands on the master node. And here, the API service of Docker daemon on manager node is responsible to accept the commands and create the service. And here, the orchestrator service is responsible for creating tasks associated with the containers of this service. And the allocator service assigns an IP address for that task, and dispatcher assigns tasks to available nodes. And finally, the scheduler instructs the worker or corresponding node for running each task. And here in our worker nodes, the worker service of Docker daemon connects to the dispatcher to get the list of tasks that are associated with this worker, and this executor service creates the container on the worker. So thanks to services, we can run multiple instances of our applications and automatically assign to different workers and maintenance them if they crash. Well, another subject for services is to use actually volumes. Like Docker containers, we can specify volumes for services, which in practice it will assign that volume to each containers or replicas. For example, here when we create the service, we can use mount option to specify the type of mount, which here is volume, and the volume name as source, and the path of a directory inside the container as destination. Let's test this. Well, Docker service create with name service1 replicas 2 and mount with type volume and use volume1 as source, and for destination the directory volume slash directory. From busybox image to run a sleep command for some seconds. It in fact will use volume1 on the node for mounting to volume directory container, but if it couldn't find any volume1 on the node, it will create a new one. Well, it created the containers on node master and worker 1. If here in worker 1 we list volumes, we'll see this new created volume 1. While here, if we connect to worker 2 and list its volumes, we don't see any volumes. So you should note that assigning a volume to a service will only create volumes on the nodes that the replicas of the service is located on. And even though here in master node we have volume 1 as well, but these two volumes, actually volume on master node and worker 1 node, are completely separate volumes and their data don't sync with each other. So if your application with different replicas on the cluster needs to use volumes, and actually the data inside the volume is have to be synced for all containers of the service, we need to use an alternative solutions that is responsible for providing a distributed object storage on the cluster. Likewise, for running databases on containers in the cluster with some replicas, we must be careful that databases data on different containers will not sync with each other. So we need to run our database in distributed manner. In fact, the database must support running in distributed mode. So in that case, even if we have, for example, 10 replicas of that database, we'll have one API for connecting or sending queries to that database, and the master agent of the database would be responsible for sending our queries into different containers. In other words, running multiple instances of a database by services doesn't give any distributed database for us. That's why to have a distributed database, the database itself must support distributed mode. And it would be responsible for partitioning or sharding our database data into different containers. And here for another example, we can use mount option with type bind for actually binding a directory inside the host into the container. But when you use bind mounts in your services, you should be careful that the path which you're going to bind to the container must exist on the corresponding node. That's why if the directory which you're going to mount into the container doesn't exist on the corresponding node, the container would be failed and the service will recreate an alternative one. Besides, bind mounts are non-portable. In fact, if your project is working on your development environment, it doesn't guarantee to work on a production environment as well, because it's possible that the production nodes missing the directory which we're going to bind. And Docker Swarm scheduler service may reschedule your running containers at any time if they become unhealthy or unreachable. So we should note that the state of our application on a node which may be stored on a mounted directory may be changed when our container is migrated to another node. And in the last part of this lecture, we can focus on publishing a service. For instance, here we can use Docker service create command with -p option for actually mapping the node's port into the container. Let's test this. Let's remove the previous service one and create a new service one to run, for example, Nginx applications with 2 replicas and mapping port 8080 on the host into 80 inside the container. It created our containers on nodes master and worker 1. So here we can verify the service by curl command, actually http on master node with port 8080. You see it returns the default page of Nginx, and if we send request to worker 1, it will return as well. And what if we send request to worker 2, which doesn't have any container for this service 1? You see it will return the response as well, regardless of the fact that this node has no any container for this service 1. Well, this happens thanks to ingress mode of publishing a service that allows all nodes in the cluster to proxy incoming requests into nodes that contains the corresponding containers of the service. For another example, we can use --publish option for actually explicitly specifying this ingress mode when we're going to publish, which in this case we must use publish parameter for specifying the node port and target parameter for containers one. Even more, we can use host mode that only publishes ports on the host containing containers. Well, in next section we will deeply focus on how this ingress mode works and all its networking stuffs. And finally, we can use Docker service logs for viewing all containers logs of a specific service. In fact, it will show all containers logs together, and we can use -f option for following new incoming logs, and by tail option we can filter only some last lines of the log. And here by inspect command we can describe a service. For example, Docker service inspect service 1. We can see all information about this service, for example, its labels and its task templates that specify how our containers must be, for example, their image and what resources must have, and its restart policy, which by default is any, and placement feature that we will see in this section. Each mode is replicated, and configuration about rollback, which we will see in later lecture, and information about ports of our containers, and the services IP, which is actually a virtual IP that allows to connect to this service without caring about containers IP. Well, in later section we will see how we can consume a service tasks without knowing their IP addresses. And Docker service remove command for removing a service that we've seen together. Well, this was an introduction for services, their lifecycle, and how we can create it and how it actually works on the cluster. In later lecture, we will focus on updating services and some other features that it provides.